My name is Serhii Sokolenko. I am a co-founder of Tower.dev. I have my co-founder Brad Heller with me today. And we are a platform for data scientists and engineers. We try to make it hassle-free. What it means is we offer data scientists and engineers open storage and compute, and we allow them to run pipelines, applications, and inference jobs on Tower. A little bit about us. We met 4 years ago in Berlin. We are not originally from Berlin. We actually moved to Berlin in the same month. Fun story, Brad and I, we first had our first team event by drinking beer in a public German park. You can do this in Germany and you will not get into jail for this. So open containers, beer consumption works. And while we were having beers and having fun in Berlin, we started talking. Brad and I, we are former founders. We actually, Tower is startup number 3 for us. And before moving to Berlin and beginning to work for Snowflake, we built data and AI systems at companies like Databricks, Google Cloud, Puppet. And one thing that we were realizing, well, actually, before I tell you the full story, to complete the team description, we are backed by a series of amazing investors, and hopefully we'll meet more of you during this week. So the story goes, the reason why we founded Tower was we are pretty engaged in the local startup community, and we got introduced to a scale-up with about 100 employees, about 30 of them being data-driven folks. And that team of 30 data analysts, product managers, marketing managers, they were supported by just one data engineer. And that data engineer did not have support of any platform team. So he had to build an entire set of pipelines, basically concoct them out of duct and wooden sticks. And we said, well, how come that in 2024 you still have to build your own data platform? Well, apparently, if you are in a smaller company, you don't have a platform team, you don't get a platform. You basically have to build your own platform if you want to use modern-day Python frameworks such as Polars, Data Fusion, DLT Hub. So all of this is being your responsibility if you're a data engineer in a smaller company. You end up building your own EC2 managed instances. You end up using things like Lambda or GitHub Actions. Now, if you are in a larger company, in an enterprise, you probably have access to a platform team, but that platform team is heavily focused on the core platform for the entire org. They're not driven by business, real-time business needs. They want standardization. They don't really care about these new modern frameworks that I just mentioned. So we want to build a platform that solves these issues for the smaller companies and the larger companies, addressing the needs of data scientists and data engineers who want to move fast. What we offer is the ability to run any Python code in the Tower platform, and we give you a portable runtime, Python runtime, that you can run on your laptop during development, in the Tower cloud during production runs, or on premises or in your cloud if you cannot really expatriate the data from your account into the Tower account. We give you a serverless orchestration capability. Now, in addition to the runtime, we give you the building blocks and there are very few of them. It's applications, tables, and models. So we think those are the 3 things you will need in any case, and we give you an easy interface to deal with apps, models, and tables. And lastly, we give you batteries. We give you additional services such as scheduling, orchestration, observability, and collaboration. Now, you can use Tower standalone in our SaaS product. You don't have to have your own platform. But if you are starting with an existing platform, such as Databricks and Snowflake and Fabric, we can nicely play together with the other tiles in your setup because we run on top of Iceberg storage. You can bring your storage to us, or you can use our storage. We give you tables, Iceberg tables. You can also bring your own catalog, or you can use our catalog. And lastly, you can deploy Tower both serverlessly, on premises, or locally on your laptops and development machines. So with this, I wanted to pass the torch to my co-founder, Brad. He's going to do a demo. Well, let me just get it started.
All right. Hey, folks, my name is Brad Heller. I'm the CTO over at Tower. Hopefully, y'all are keeping up. We're in pretty early days here. We're in early access. You can sign up for Tower if you like on tower.dev. We're hoping to find more folks to help us out. A little bit about how Tower works. Everything in Tower is an app, and an app is all the Python code that you and your teams builds and maintains. When you invoke an app, we call that a run. You can invoke an app in lots of different ways. Apps can invoke other apps. In this dashboard, I've got lots of runs, for instance, here. And apps typically run inside of environments, things like staging and production. And environments contain secrets, which get injected into your applications at runtime, as well as catalogs, which is how Tower understands your Iceberg data. Right now, we support the Polaris-based catalogs, but we're adding more soon. Shout out to the Lakekeeper guys. So now that you understand a little bit about how Tower runs, so Tower runs run inside of our serverless runtime environment. What's important to know about our runtime environment is that it's separated into a control plane and a data plane, and you can download and install the data plane in your cloud, or you can use the data plane in our cloud. So enough about how Tower works. Let's look at a little bit of code. So I wanted to create a relatively interesting example for this conference. I wanted to create an AI that helped me make decisions about what stocks to buy. I'm pretty bad at this stuff. This turns out to be an interesting example. It's separated into two components. One is a bit more data engineering focused. The other is a bit more data science focused. We'll clone the repo. We can look at it here in Cursor. So here's both apps. One really important thing to understand about Tower apps is that every app has a Tower file. And the Tower file is kind of the interface between the Tower system and your code. It describes how we should package the app, how we should invoke it, and a bunch of other stuff that we'll walk through. For instance, it describes, what's the name of the app inside Tower, what the entry point is, or the script you should invoke, any source you wanted to package along with it. If you include a requirements.txt or a pyproj.toml, we'll use that for managing dependencies. You can also specify things like a schedule or maybe some parameters that you might want to use to let your users control the behavior of the app. Let's look at the actual Python. It's important to note that Tower can run any Python that you give to us, but we distribute a little SDK that makes it easier to use a few features inside of Tower. For our Iceberg-related stuff, we use Arrow, so everything is described in those terms. Like, for instance, this table schema here is described in Arrow. And then going down to the sort of main function here, it's pretty straightforward. The first thing that we do is call tower.tables to get access to the daily ticker data table. This create if not exist function does exactly what you think it does, creating the table with the relevant schema defined above. This download function is boring, ignore it, just takes some JSON data, turns it into Arrow from the internet. And then finally, once we have the data, we just blindly insert it into the table. It would be nice if we made this item potent, but it's a pretty simple example. So now what can you do with this thing? First, you can call tower deploy, and our CLI will package everything up and ship it off to our servers to be ran. And then you can call tower run to run it in our cloud, or you can call the --local, add the --local flag, and then our CLI will instantiate the runtime environment on your laptop and run it locally. Now, we're going over to the data science-related workload. Again, you see a Tower file here. And the Python looks pretty similar, realistically. The first thing we do is call tower.tables to get access to the same table. But this time we call the .read function to get a data frame over the table. We then pass that into this analyze data frame function, which does some data science magic. For instance, it calculates a 7-day and a 30-day moving average, a volatility score, a trend line. I'm pretty bad at this stuff. My buddy Claude helped me out with that. And then we filter it down to the parameter that the user passed in, the date as of which we want to perform the relevant analysis, print the data frame. And then what we do is we compose this into a prompt that we're going to send to an LLM to get the recommendation. In this case, we're using the DeepSeek R1, so we call it tower.llms, send it the prompt, and then we'll actually run this thing inside of Tower. Click create run. We'll just use the default date settings. And we also invented a technology that speeds up time. And here we go with the data frame. So you can see the data frame that we're actually working with. And then, here's what DeepSeek thinks about my portfolio. It says I should buy NVIDIA and Google. which actually that might be a good thing to do right now. Yeah, that's it. That's Tower in a nutshell. Real whirlwind. Happy to chat more later on. Yeah, back to Serhii.
Thanks, man. So I've got one last slide, and that's basically just a way to get in touch with us. We are looking for design partners. You've got my contact information. Take a snap of the QR code. We would love to talk to vertical use cases. If you're, let's say, building a decision platform for the insurance industry or some automotive use case, we would love to discuss how we can help you with data processing, AI inference, and so on. Thank you, and I see you in the audience.